We are on day 2. We are preparing for Algebra 2, right? So, systems of equations. This means I have 2 equations and I need to come up with an ordered pair that would work for both the x and the y. If I plugged it in for x and I plugged another number in for y, then it would work, it would plug in properly into both equations. So there's 3 methods. The first method is graphing, okay? With graphing, the solution is the point of intersection. Okay, so I'm going to look at these first 4. I'll do number 1 and I'll do number 3 with you. I think, I haven't told you yet what's going to be for homework. Anyways, you'll do number 2 for homework. Maybe that's all. This is easy. This one's easy. So first method is graphing. I'm going to graph a straight line. Okay, we're really talking about graphing tomorrow, but with these 2 problems, it'll be fine. I've got y equals mx plus b. The m is my slope, which is my rise over run. My b is my y-intercept, and that's where I'm going to begin. That's where you begin your dot on a graph. So that means that I'm first going to do this top equation. And I'm going to graph this. My slope is like -8 over 3. The negative sign goes with the numerator, negative numerator. And my begin is at 4. So B, y-intercept. Your line is going to cross the y-axis at 4. There it is, 4. Make a dot at 4. Then my slope is rise over run. Rise -8. Down 8, run +3. Right 3. Down 8, run 3. Down 8. From my y-intercept, I go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Run 3 to the right, positive. 1, 2, 3. Okay. So then, get a straight edge. Arrows at both ends showing that this line goes forever and ever in both directions. Then, let's do the second equation. My slope is -1 over +3. My begin is -3. Okay. Do you guys see how when the slope is negative, it means downhill line? I don't know if you remember that from Algebra 1, but that's the case. So I'm going to begin at -3. Y-intercept, y-axis, -3, make a dot. Then I'm going to rise and run. So I'm going to do rise -1, down 1, 3 to the right. So my y-intercept, rise and run now. Down 1, 3 to the right. Oh, I also want you to reverse it, which means you go back to the y-intercept and you go the opposite direction. So instead of going down 1 and right 3, I'm going to go up 1 and left 3. Okay? Then that means that I'm going to connect the dots. My solution is the point of intersection. The point that these 2 hit is 3, -4. Okay? That, if I plugged in 3 for x and -4 for y, I would get that the left side equals the right side on the top equation. If I plugged in 3 for x and -4 for y, I would get that the left and the right side equal each other. So that means my solution is 3, -4. All right, good. Now, number 3, it's your job to change them to y equals mx plus b first. It means I need space. Change this to y equals mx plus b. This is standard form, and I want slope-intercept form. So that means that the y is alone on the left-hand side. So I'm going to have you first get the x over to the right-hand side. So I'm going to subtract the whole thing, 5x, and I actually put it up here. The reason is because now my left side says 4y, but right after the equal sign has to be your x term. So I don't want you to combine the 5 and the 8 at all. You have to keep them separate. 5 has an x and 8 does not. So I'm going to put negative 5x minus 8. Keep them separate. Then, I'm almost there. My y is almost alone. Then I'm going to divide everything by 4 to cancel out the 4. Y equals negative 5, 4, x minus 2. My slope, negative 5 over 4. My begin is at negative 2. Let's graph that one now. Let's just do it. Y equals mx plus b. Sometimes it's minus b, you know? Okay. Begin at negative 2. Then I'm going to rise and run. I'm going to rise and run. Rise negative 5. That means go down 5 and run 4. Positive 4. I'm going to go off the graph. That's okay. You just imagine where the spacing would be. Down 5. 1, 2, 3, 4, 5. That's fine. Run 4. Like, I don't know there. If I want to reverse it, I go back up to my y-intercept, and I'm going to go up 5 and left 4. See how it's a negative slope? Negative slopes mean a downhill line. Up 5, left 4. Connect the dots, la la la. I sing songs for, I am just a giant dork. And I don't care if you laugh at me because I don't mind being a dork. So I have now graphed the first, this was standard form. Here is slope-intercept form. I have graphed it. There it is. Next, x minus 4y equals negative 16. Change this into slope-intercept form. So I'm going to move the x over and then divide by negative 4. Remember, I put it up here. So the x is gone from the left. There is still a negative 4y. There is still the negative sign in front of the y. Right after the equal sign, it needs to be mx plus b, right? So negative x, if you want to put negative 1x, you can, minus 16. Then, this negative 4 is multiplied by the y. Let's get rid of it. Negative 4, let's divide to get rid of it. Everything gets divided by negative 4. Negative 4 divided by negative 4. Positive 1y. I'm ready. This is y equals negative 1 divided by negative 4. Negative divided by negative is a positive. Negative 16 divided by negative 4 plus 4. My slope is 1 over 4. My begin, my y-intercept is at positive 4. Here we go. Let's graph this. Begin at 4. Way up there. Rise over run. Rise 1, run 4. I'm going to run out of space, so let's do 1 dot. Rise 1, run 4. Up 1, right 4. Rise 1, run 4. Reverse it. Down 1, left 4. Yeah, Great. The point of intersection is very clear to us. It looks very nice. The solution to my system is where the two lines intersect. -4, 3. Very similar to number 1. So this is how you solve a system using graphing, okay? You see where the two lines intersect, and that is your solution. So you guys, you know what? That was wrong. I want you to practice changing to y equals mx plus b. Let's make number 4 homework. That's solving by graphing. The second way to solve a system is by elimination. Elimination is when both are in standard form. And you're going to cancel out a variable. You cancel out a variable, you guys, by the variables, like they have to be the same number. So I need them to be like, both of the x's need to be the same number, but different signs. So we got to do some practicing here. So really got to make sure that you're clear on this. Okay. See on number 5, how this is a positive x and this is a negative x. If I add the equations, the x's would cancel out. So now I have nothing for my x's. So a variable canceled out. Now I have 2y plus -8y. That's -6y. Then I have -4 plus 10. That equals 6. So I have isolated one of my variables, and I am now able to solve for y. Solve for y means that I divide by -6 to isolate the y. Y is -1. That means that I'm halfway done with my ordered pair. Because you guessed it, I need an ordered pair answer for all systems. Okay, number 5. I know what my y value is, but I don't know what my x value is. So I'm going to use this information, y equals -1. I'm going to plug -1 back in for either top or bottom. It doesn't matter. If you think the top equation looks nice and easy, plug the -1 in there. If you think the bottom one looks nice and easy, plug it in there. The numbers are smaller on the top equation, so let's plug this -1 into the top equation where the y goes, because I know what y is. Y is -1. So here's my second equation. X plus 2y, because y is -1, equals -4. 2 times -1, x plus -2 equals -4. Solve for x. Add 2. X equals -2. So that means that my solution to this system is -2, -1. Okay? So now that's nice. You can do number 6 as a practice because look, the y's are going to cancel. So I want you to do number 6. Then there's some problems where you have to multiply one of the equations by something to get it to cancel out. So I'm going to do number 8 for you for notes. And I'll give you 7 for homework. Okay. Here we go. I could make both of these x's into an 18, or I could make both of the y's into a 3. Remember, the signs have to be opposite. I need a positive and negative. Because the way that I teach it is that I want you to add the system every time. I don't want to worry about subtracting. So if I want you to add the system, that means that I'm going to want the signs to be different so that they cancel out. A positive something and a negative something. Should I make both of these an 18 or should I make both of these a 3? Well, if I look at it, it would be easier if I made both of these a 3 because those numbers are small, right? So that means that this is already positive 3. So then I look down at this like 1, right? It's like a 1. And I need to figure out how am I going to make this y, this 1y, become a negative 3. Remember how I want opposite signs? So what am I going to have to multiply the whole equation by to get this 1 to become a negative 3? I hope you said negative 3. So here we go. The top equation didn't change at all. I'm going to write it again. But the bottom equation, I'm going to distributive property multiply everything by negative 3. Negative 3 times negative 6y, positive 18x. Negative 3 times positive 1 is going to be a negative 3y. This is good, guys. Negative 3 times 0 is going to be a 0. What's happening is everything is canceling. Nothing. When I add these equations, negative 18x plus 18x is no more. 3y plus negative 3y, no more. But I still have a negative 4. This is going to be a no solution. Which means, guys, parallel lines, if I graph them. Okay. What's going to happen with number 7? Yeah, number 7 is going to be kind of like that too. Number 7 will be very similar. You'll see when you get to it. 10. This will be fine. Hey, they're already both 8s. So I need to make one of them opposite sign. Let's do the bottom. It does, well, sure. Okay, so I'm going to multiply by negative 1 so that I have a negative 8 and a positive 8. When I multiply the bottom equation by negative 1, I get an 8x, I get a negative 7y, and I get a negative 15. The top equation didn't change at all. So I'm now able to cancel out the x's. So I'm going to add the equations. Here we go. Gone. 6 plus negative 7. 14 plus negative 15. Great. Negative 1y equals negative 1. Divide both sides by negative 1. Y equals 1. I'm halfway done with my system. Since I know that y equals 1, I'm going to pick either one of these original equations and I'm going to plug a 1 in for y. Pick the bottom one. Why not? Negative 8x, the bottom one. Negative 8x plus 7 times 1, because y is 1. 7y, 7 times 1. Minus 7. Negative 8x equals 8. X equals negative 1. Okay? All right. I want you to do number 11. I want you to multiply the bottom equation by negative 1 first. So don't worry about 9. Don't worry about 12, because my video is already at 19 minutes. I gotta hustle up a little bit. Okay, I'm going to jump down to 15, 16, 17, and 18. Substitution method can be used when either the x is alone or the y is alone. Okay? All right, the substitution method only works when there's either an x alone or a y alone. So these last 4 problems, we're going to use the substitution method. I'm not going to eliminate any variables. I'm going to solve for one variable at a time, though. So here we go. Let's start with 15. This is good. They're both y equals. Okay? So think about this logic. If Sarah likes dogs, and then Tim likes dogs, then can't I say they both like dogs? So I can say Sarah likes dogs, and Tim also likes dogs. So Sarah likes Tim. They have something in common. They both like dogs. So that's what's happening here on number 15. The y is the dogs, and then Sarah is the equation. So I've got the dog is y, and Sarah is here. But the dog is also the y, and here's Tim. So when I know that they both like dogs, I can say, hey, Sarah and Tim like each other. They have a commonality. These equations both are equal to y. So I can set these two equations equal to each other because they both are equal to y. So I'm going to go, Sarah is the same as Tim. They both have a common dog preference, Okay, they both like dogs. I'm going to set Sarah equal to Tim. And then since I'm able to set Sarah equal to Tim, this is called substitution. I basically said, hey, if 8x plus 21 equals y, then I can plug in 8x plus 21 in there for y because it equals y. Now I'm able to solve for just x. So this is just a two-step kind of thing where I'm going to have to get the x's together and then the 21 and the 11 together. So let's move the smaller x over so that I always have a positive, well, most likely a positive x. Okay, subtract 3x both sides. Then I want you to minus 21. 5x equals, negative 10, sorry. So lastly, divide by 5. X equals negative 2. Negative 2 comma something. My x is worth negative 2. Since my x is worth negative 2, that means that I'm halfway done with my system. My solution is negative 2 comma something. Now, I'm now going to solve for y. Since I know that x equals negative 2, I can plug negative 2 for either one of these equations. I think that the bottom one looks easier. So I'm going to say, hey, x is negative 2. Y equals 3x. Oh, x is negative 2 plus 11. Y equals negative 6 plus 11. Y equals 5. So negative 2, comma 5 is my solution. And I wrote it right here. In an instance like 16, so you're going to do 17 for homework, and you're going to do 18 for homework. In an instance like number 16, sorry, I had to drink water. Y is equal to this. So 2x minus y, here's what y is. Y is 2x plus 4 equals negative 4. This is gonna, all right, hold on. You'll see what happens. 2x, distribute negative times 2x, negative times 4. This is a good one because the x's cancel. So it's 0 minus 4 equals negative 4. And then I add 4. This is not no solution. These are not parallel lines. These two, when the numbers cancel and the variables cancel, this is called all real numbers or infinite solution because it's actually the same line on top of each other. So they have the same set of answers if I were to graph them. All right, so your job is 17 and 18 for homework. Remember, you're substituting. You're plugging in this negative 3x in for the y. You put it in parentheses. And then you solve for x. Okay? All right, this is good. I think, oh, you guys, we're done. 25-minute video. Excellent job. We're done with day 2, systems of equations.